All right, well, welcome back. And I'm doing what probably you're all been waiting for is we're going to be trying to figure out what is the transformation, what does this transformation of the secant graph look like? Am I right? Am I right? I'm right. Okay, well, first off, our favorite secant graph. So if you think about the secant graph, okay, let's just kind of write out our points. So secant kind of starts here. And if you kind of just draw out the little graph right there, you know that it is the reciprocal of the cosine graph. So cosine starts like that, so at 0, 1. Then at pi over 2, or oops, this point right there, pi over 2, you know it's going to be 0. Well, at every 0, it's going to be a vertical asymptote. And so that's why right here at negative pi over 2 and pi over 2, we're kind of going to draw this vertical asymptote right there. At pi, we know we're going to be at negative 1, so we have a point right there. And then right here at 3 pi over 2, we know that we have another 0, so we're just going to go right there. And so we have this graph. Now this is just a regular secant graph. It's going to look like this. And then it keeps on repeating. The period of the normal secant graph of x is pi over 2. Okay, pi, or sorry, not pi over 2, 2 pi. Bad talk. Okay. Okay, so it's equal to 2 pi. So what does that mean for our little transformation here? Well, right here, let's just think about what's happening. Well, first off, all of our y values on this secant graph, all right, are being multiplied by negative 2. So all the original ones are being multiplied by negative 2, and then we're adding 2 to them. Okay, so what does that mean? Well, if we start with this vertical asymptote, what vertical asymptote does, it just stays a vertical asymptote. Nothing really changes, okay? Unless you're moving it right or left, it just stays the same, okay? And so we're going to be staying right there. The next one is, okay, then we go to this 1. So what is 1 going to happen? Well, 1 times negative 2 is negative 2. Okay, so we're going to take that 1 right there, and then we're going to add 0. Okay, and then we're going to add 2 to it, and then we're going to get 0. So we have this new point at 0. This value right there, we have another vertical asymptote. Okay, so we'll just go with vertical asymptote right there. And then right here, we have another negative 1. Well, what happens when we have negative 1? Well, negative 2 times negative 1 plus 2, that's going to turn to be 4. It's going to be 4. And then finally, we have another vertical asymptote for our last point. Okay, so now the question is, what happens to our x values? Well, our original x values were divided by 4. So our period, just like when we find normal periods, so our new period to this new function is going to be 2 pi divided by the b value. In this case, our b, all right, this is our d and this is our a. Okay, we're going to 2 pi divided by 4, which gives us a value of pi over 2. So our whole period is going to be pi over 2 units. Okay, well, that really shrunk it down. Okay, so this is our new period. Okay, this is our new one for this transformation right there. Okay, and so now what is this going to look like? Well, we're dividing all of our x values by 4. We're not shifting anything right or left. There's no phase shift here, but we're dividing all our x values by 4. So all of these original x values are going to be divided by 4. So we started here at negative pi over 2. So we're going to actually have negative pi over 8. Okay, because we took pi over 2, negative pi over 2 times 1/4. We get that. 0 is going to stay at, well, guess what? 0. Pi over 2 is going to be pi over 8. So this vertical asymptote, these all shifted and were shrink down, all right, to negative pi over 2 and pi over 8. And then over here where this this max is, that's going to be pi over 4. Pi over 4. And then finally, our last one is going to be 3 pi's over 8. And that's what we got there. Okay, and so what's happening here? Well, if we graph out this new, all right, secant function, what's happening is that it appears right there. Okay, what we have is, all right, if I go by pi over 4s, pi over 4, all right, so this would be then pi over 2, okay, and it's going to be negative pi over 4. We realize that each one of these is going to be half in between. So right there, it's going to be like, probably should change my color so I can make a better sound. All right. Okay, we have that. Our 0 is still going to be here. It's going to be at 0. Okay, because that was moved. Right there, our pi over 4 is we have pi over 8, which is going to be like right here in the middle. La, 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 la. Okay. This one right here is going to be pi over 4 is going to be 4. So we can go uno, dos, tres, cuatro. All right. We got that right there. Then finally, 3 pi over 8 is going to be like right there. La, 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 right in the middle. Now, in looking at this, everything's being reflected. So that's why this negative right here is a reflection. Okay. So this is a reflection over, okay, the x-axis. Okay, and so instead of going up right here, you can see that, yeah, that's going to go down, okay, because everything is reflected. Right here, instead of going down, it's going to go up. So instead of being a max, it's now a min. Instead of being a min, now it's a max because everything's been reflected. And then we can continue on, all right, these same type of things. So we can have another one right there. All right, go like that, and you can find another one to be right there. Okay, like this. Whoop. Okay, and we keep on going onward and forward. Okay, and so on and so forth. Okay, and we would have that. And this is it. This is the graph of that secant. And these are our points. And this is how you figure out. Cool, huh? I thought you would think so. But let's do one more, all right? And so I'm going to put one more in here, okay, of a cosecant. Actually, I think I'm going to stop this and do the next one. All right, it's a little shorter. So hold this out to the secant. We'll come back with another one with cosecant.